Hello. Today we are continuing with Automat and assembly widget. As I mentioned during the last stream, I took some time offline and implemented some of the missing features. So now the code that we developed over the last stream, or the last two streams probably, where we had this new machine code controller, it's actually worked. It's actually used by Automat. I can show you. Let me grab a more interesting instruction, maybe something that and let's run it. So this is our assembler, and we just incremented the AX register. So now it has value 1. Now I can actually run this in a loop now. Bam. So now it's continuously running, I think. Oh no, I'm not updating the code properly. Let me try this again. We need to still update some things. We don't update the assembly when we play with the connections. This is another thing we should do. So when I actually create a loop, so now we have a loop which increments a register. Now I can start it, and we immediately see that, hey, those values, they are changing. They are only being updated when I actually zoom in and out, which is not perfect. But we are actually reading at 60 FPS the state of register from another thread. By timing this video, you can probably tell that the frequency of my CPU is around 5 GHz. Pretty much. So this 32-bit register basically wraps around every second. So this is kind of like a second counter here, which counts how many seconds we have. And the flags are progressing further and further. Many things we need to fix here, but the one which has been bugging me a lot for a long time is this one. This was supposed to be axolotl, a pink, cuddly salamander. But for some reason the flags doesn't know what it means to be, what is an axolotl. Luckily, I managed to find, totally accidentally, this thing. So apparently there is a guy on Civit AI who really likes axolotl and is very good at fine-tuning models using LoRa's. So he's training LoRa's for models. He specifically trained this LoRa, and we'll start the stream by actually improving the axolotl model that we have using this LoRa. I already downloaded this LoRa to my downloads folder, and one more called cheats. So what we are going to do is we are going to take those two safe tensors files. I'm dropping them in the conf.ui directory for LoRa's. So now we have axo model and cheats. Then I restart conf.ui because it has to restart to pick up new LoRa's. Cool. And now we can actually start Krita. Let's see. So we have some Krita files. I want to see this one. Okay, there was a new update. Cool. Yeah, let's download the update. What can go wrong, right? And now we restart Krita. Cool. I'll just call this hand with flag. I'll hide all the others. And let's go back to our prompt, which we used to generate. We'll switch to my flags. So this is the prompt that we used to generate our current axolotl. We can, just to see, we can generate one more, or 5 more. Anyway, let's generate. In the background, ComfUI is starting out. So we should see basically the same crap that we used to have so far. It's loading flags and we should see our lizard. Sorry, salamander. Is salamander a lizard? Okay, no it's not. It's an amphibian. Interesting. Okay, and you can see we are getting... Actually, this is a nice one. This is much better than previous ones, but it still doesn't have the signature gills. So if I understand correctly, the axolotl breathes through those things on its head. They are like inverse lungs. They have a very high surface area. Yeah, it looks like a dragon almost. So now, what we are going to do is I'm going into styles. I'm going to add a LoRa. This is going to be, let's find our axolotl. Yeah, perfect. Okay, I'm not going to add any trigger words here. But let me just check one more thing. Okay, this one doesn't have any trigger words. Good, good. So let me add one more LoRa, and this is going to be these cheats. So this LoRa is a very abstract LoRa which forces flags to create slightly more aesthetically pleasing images. So Schmede, the author, the guy from this interview, he basically chose a few images that he likes. He put them in a directory and trained LoRa with that. And this is how it actually affects the generation. So before, the generation is very simplistic. This is like what Flags normally generates. And with the LoRa, it's slightly more epic. I know, maybe we'll want to disable this, who knows. But if you look at this, this is just much better. Those on the right. This looks like a low quality AI generation model, and this suddenly looks like a high quality one. By the way, he uses a lot of videos. This is something we could also do, because generating videos, once you have an image, it's actually easy to generate a video out of this if you have ComfUI. Anyway, I'm saving this. those are our 5 axolotls initially, and let's generate a new batch, now with the LoRa's enabled. Look at this. It looks the way it should. It's perfect now. It is highly detailed. Maybe we'll disable the cheats LoRa. Let's wait. Let's give it time. Let's make it generate 5 images and then we will decide. So much better. Again, so much better. I think this LoRa, it had some pink frilly gills around black eyes. This one is broken. Let's look at other registers that we have. Those are fairly simple images, I would say. Yeah, let's try without the cheats. This one is way too fuzzy, but I have to say, even though they are looking badly, they definitely follow the prompt, because I said I want a medieval illustration, medieval painting, and those are actually more of medieval paintings than those. Okay, I will click generate. I will crank this up to 10 and go and make some tea. So be right back. I say came just in time. The generation is finishing. Okay, they are great. We didn't need the cheats, Laura. Okay, this is my favorite so far. Just looks nice, right? I am definitely keeping this one. Those can go away. Let's discard them. Maybe you can say more about what kind of salamander this is. I actually wanted the salamander to not be dressed, to be like a very saturated image of not a humanoid salamander, but something closer to an actual salamander. Let me take a look at some prompts that have been used here. Come on. Okay, let's try Disney. Let's go down to 5 samples and generate. And let's look at the others. I don't want to have clove salamander. I want them to look more like that. Cute. Maybe I can just say it's cute. Okay, we can say it's tiny. Tiny, adorable, cute. I think this produces them in their natural state. Feathery gills. I think those with feathery gills are important. Let's add them. This Disney isn't giving us what we wanted. It's more saturated. It's definitely more colorful here. Right? This one was very muted compared to those. It's a slightly different style, completely different style. There's not much of an illustration there. It's more like a render here, or a photo. I like the pink frilling gills. They should be very intensive. It should look cute, fun, right? So this thing here is great. And I like that they have open mouths and they have these teeth, like from the How to Train My Dragon. How to Train a Dragon. I'm not sure if they actually have teeth, but they look good. King, actually, crown is very good because the AX register is kind of important. This is like the most powerful register in your CPU. I have to say the level of the results with this LoRa compared to the stuff that we had before, so much better. Okay, let's generate the cute ones now. I've added them to the queue, so we will have one more non-cute. For some reason they are always wearing clothes. Tiny. Maybe if we make it tiny, then it will not have clothes. I think that could be the key. The cute ones are cute, they are more baby-like. Still, probably this one is my favorite. I think it fits our style quite well. I also like the king. This one has great face. But everything else just doesn't fit. Let's try some of the tiny ones. I'm a little bit afraid to explicitly say that it should be kind of naked. It's a cartoon, right? It's an animal, but I have no idea what the model will generate. Almost good, almost. It has a body of a human though, so that's a problem. Only mammals have nipples. I would like to copy this prompt. Again. And I would like to generate 10 more of those. No, cancel. We can just describe what we want, right? Can also try something totally different. Holy crap. The one with flag at the top of the head. Yeah, this is AI. I think I may have queued a few too many pictures. But okay, while we are waiting for them to generate, we can do other things, like do this. The assembly should follow the next connection. Fire cursor. I have this exit callback already, which should be called whenever an object finishes execution. Yeah, it was called. So I guess we can use this. So here we are getting the instruction, this weak pointer. So what we kind of need to do is first of all, we need to get the current location. Actually, no, we may not even need the connection. We have I think an array of instructions. No, we don't. Yeah, so we need to get the location. So we are finding all of the instructions that are pointing at us. This is a weak pointer. Okay, if we reached this point, then it means that we are exiting from this location. Probably not need to specify this. So the name, regarding the naming, the name only has to include the parts necessary to differentiate this variable from others. Yep, that's kind of all we need. Who is the generation? I think this one was still nicer. I think when we are saying about those pink frilly gills and other things, we're kind of forcing the model to do something that it just doesn't want to do. Okay. When exit happens, when we are quitting assembly, then we should mark all of the instructions . should set this to null, but let me just see how do we do this. So we first should call cancel. Actually, no, we don't have to call cancel.
Ian Tixera says,
We're at CPP, crazy.
Yep. Okay, this long running is a marker that we are using internally to indicate which instructions, which objects are kind of busy right now. When we are executing assembly, we should mark them all as busy. So this is the long running pointer. We should clear it when we finish. But this one is important. So when we exit, okay, this is not what I want to do. I actually want to do the next one. Okay, apparently it's here, schedule next. Okay, I think this should be enough. So now instructions should be calling their successors. Let's try with this one. Let's call it here. Let's create a loop like this one. I think I may be out of memory. Yeah, my computer just locked. And this is probably because I have TTS and at the same time stable diffusion and at the same time cursor, which is also probably running some models locally. Okay, we are unblocked. Okay. We got some actually nice images. Not this one, this is just scary. Something like that. This is what I wanted. But it's a little bit too cute. I don't know. It doesn't fit the others. The flag in particular. Holding a red flag. Yep. Let's try again. Starting Automat. One more attempt. We have to be fast before it crashes. Okay. This is because of memory. If I open BTOP, my GPU use memory is 98%. Yeah, so when I'm running CompUI, it's really using all the memory that it can. Some of those axles are creepy.
Holy.
Okay, this is the style I wanted to go for. Maybe we could use that, I don't know. Okay, we have 10 more images queued. The next ones that I have queued will show axolotl wrapped around the pole. It's not what I wanted. It's almost like a snake. This is what I was thinking about. Like the caduceus. Is this how you pronounce it? Yeah, this style of wrapping. Okay, no, this is just looking terrible. You know what? Let's take this one. Let's put this down to something like 70%.
Directly for Mib.
Okay, now I am just fine-tuning this image. Maybe we can make it work, who knows. The flag is something I would like to fix. Suddenly it's much uglier. Oh, because the prompt is different. Stop, and let's do it again with a different prompt. The original looked the best. That flag, honestly, that flag is the one thing I would like the most to fix. Yeah, it should look like this one.
everyone.
Hey, Knight. Okay, this one that I liked, I will save this. This was a good alternative, but we'll try to improve this one. We just want the flag to look more like that. Okay, you know what? Let's cancel all of this. Let's do some photo montage. We also need to get rid of this hand. I can actually potentially copy a fragment from here here. Okay, so we got rid of the hand. Now let's get rid of the white color. Okay, now we have a flag. Pretty much just the flag. Now we can remove this one.
Ian Tixara says.
That's my absolute last one.
Yeah, I don't know what voice is that. We have some issues with TTS. But yeah, Krita is actually, in my opinion, this is the best way to use Stable Diffusion. It beats Comfy, so it's not as flexible as Comfy UI. Obviously, with Comfy you can basically program, whatever workflows you want. But what you get is really nice UI that has great defaults, so it can actually configure Comfy UI for you, this plugin. It's called Krita AI Diffusion. And it is still fairly flexible. So loading LoRa's, for instance, this is just so polished. I can, just say, hey, I want this, for example, RPG portrait LoRa. And whenever this LoRa is enabled, I want to have some, extra trigger words. Really good. Actually, I wanted to have these cheats. Where is my cheats? I will disable this. Okay. Anyway, so this is our axolotl. It's also maybe try to fix this part. Oops. Anyway, it's not looking bad. Maybe there's more things to fix. Sometimes it's basically necessary to do some tweaks because AI sometimes generates random garbage. Okay, let's merge those and now let's refine them. You can see how this kind of edits, where I can take a couple of generations, combine them into a single one, and then refine them again with a slightly different prompt. It's just so fast in Krita. It's really trying to dress our lizard, our amphibian, which is not what we want. So honestly, we could probably just use this image if we wanted. Okay, this one is nice, this one is better. This one also nice. I think this one fits our style better. Too many fingers, obviously, as usual. But it fixed the hand. Now the hand looks good. The flags look nice. Okay, we don't want those with clothes. This one is nice. This one is thinking, right? It's looking up and, And it matches the style. Nice shadows. I think we'll go with this one. By the way, it's trying to put the clothes on this axolotl, but this is just an issue with probably how Flux was trained, because this LoRa, after watching this explanation, it seems this was trained with high attention to detail, so that it doesn't really pollute the meaning of the axolotl with tangential content. So the term in a prompt, when you put axolotl, it really just captures the essence of the axolotl in different art styles. So it's not necessarily... So it's also nice. A little too baby-like. This should be a little bit scary, I think. Scary but cute. A little bit uncentric, like David Lynch movies. Like surprising. A little bit unsettling but still pleasurable. This is too much. This is just kitsch. We are going with this. I like the change. So we are going to remove the background now, using our standard procedure. Okay, maybe this box selection will work. Let's see. Okay, it's not super accurate. We have to go with color, because the AI tools are just not accurate enough. Let's try this. Or actually, I forgot one important thing. Filter color. Sorry, adjust levels. So because this image is not generated with perfect white, it actually has near perfect white. But if we just trim this, it makes the background perfectly white, so it will make our mask just way better. You can also take a look at those things. Yeah, let's do this channel by channel, because I see some weird artifact in the blue channel. It will also do color balance for us, if we do it like that. So now the color palette is neutral. Now when I go to levels, looks clean, logarithmic also. when I show this on a black background, we can see the places where we had issues, but we can fix them manually. I'm putting more attention to the AX image, to the axolotl, because this is the most important register in the CPU, in x86. It's like pretty much half of the operations that you do end up affecting this register. Maybe I should paint it instead. Oh, maybe I can use patch tool. There is probably a trick that digital artists use that I have no idea about for subtracting the color. If I just use white and subtract, it will probably do something totally different. Let's just paint this over. Okay, I guess this is good enough. This is our new AX. We can compare with the old one. The old one looked terrible. Absolutely terrible. Let's get rid of this. Oh no, I missed the shadows. Okay, I can fine-tune it more and add the shadows back. Now let's just run this refine. Okay, it's not doing a good job. Let's just go back to the original image. When I do the color selection now, I can see why we didn't pick this up. Yeah, suddenly it's too much. Actually, yeah, I guess I can do it like that. I think I found the trick finally. This again, red, green, and blue. Oh, what happened here? I know. Quick test. Yeah, looks much better. There are still some artifacts, but I think we don't need to fix them anymore. They are very subtle now. Let's call this AX. This is our new. I can get rid of this new AX register. Great. Now we can save this. So bad. So quality 80%. Now we can see how it looks in Automat. Great. Now it looks so much nicer. And we can see if the loop is working now. Here we have a loop where this increment happens every 5 seconds. I can start the timer. In a moment we should see the assembler. It crashed. Assertion not scheduled failed. Let's see. So scheduled is just a boolean. When this assertion fails, I would like to print more information. task for delay already scheduled. So we definitely have these most register updates. So we can see that the value of AX increments every time we execute this instruction. I see two issues. We should see none of those. First of all, we should not see this task already scheduled thingy. Let's see if we'll see this error now. Okay, now we didn't got any error. Okay, but the next connection didn't flash. It should have flashed. So normally when you're finished, this should blink. But it didn't blink. Okay, so this is what happens. Timer runs, it schedules itself at some point in future. Timer finished task, okay. We're going to timer notification. Okay, so it's just calling done. And what does the done function do? It resets the long running. And calls schedule next. Sure if name actually contains anything. Yeah. Okay, this scheduling next was called many times for some reason. Oh. This is what we wanted. It should be equals. That was the issue. Now when I run this, yeah, it properly blinked. I think when I create a loop now, it's not going to really... Okay, it actually looped for a while. Yeah, that was just a super fast loop, let's say. And now it's broken. But yeah, this exit callback looks okay. It was my mistake here. As always, actually. Now this should be a proper timer, which increments every second. If I do this, it should increment every second. Cool. There is one more thing which I would like to fix, and those are the loops, right? When I have instructions that work like that. Sorry, maybe I will restart. Okay, so we executed this. So we incremented the AX, it's incremented here. We compared it with 10. We did that, but the jump instruction, it didn't work. Because we still don't support jumps. So let's do jumps now. many things we have to fix. Okay, if there is a jump, actually we could do a nice hack here. Oh yeah, it's going to be such a nice hack. I'm just thinking about the correctness of this. So we have a weak pointer to the instruction of, not object, to the instruction of the descriptor that was the last one in the machine code. And we actually could translate this to a pointer to the instruction object because we know the layout of the instruction object in memory. We know that it has this mcinst at offset 40, so we just need to take the address of this, subtract 40, and we have the instruction. So we have pointer to this, and we want to pointer to this. I think we can do that. Okay, so we have this. So first, we want to check if this shared pointer is pointing at anything. Then we can get the row pointer. This is unsigned long, so no, but we can store this inside an integer. Let's do char. Actually, let's remove this here. Cool. Okay, this can be null pointer in some situations, so we have to check for that. Can mostly remove this. Here we have to schedule the jump somehow. I think I will get rid of schedule next and replace it with something slightly different. We are not using this in many places. The idea here, and by the way, we will also remove the last finished. Instead of schedule next, let's have there is an issue because it creates a cyclic dependency, but I can always say struct argument exists. So we'll have something like that, but not exactly. This last finished, I want to change this. Okay, maybe I will keep this as a shorthand for schedule argument targets with next. This last finish is wrong because it causes the wrong connection to blink. By the way, in the assembler we can now do this.
Marek Kowalski says.
Hello, what's up?
Hey. All right. We are kind of crashing it. We are getting to do after to do implemented. If we're lucky, this should actually execute now. Okay, we incremented AX. This one didn't blink. It should have blinked, I think. Let me decrease the frequency. Yeah, the blinking doesn't seem to work now.
There's so many ways to black doing stuff.
So whenever we render, whenever we draw, so this is not actually draw, whenever we record drawing commands for this widget, we are sending a request to the debugger, and debugger reads the current values of registers for us. Unfortunately, this doesn't quite work. I don't know why. Maybe I'm using wrong condition here. Yeah, this is why the assembler widget is very... It's missing a lot of things. We should have flags, so... And I should be able to execute this instruction by instruction, so in a step mode. It should have this, hand that points to other instructions, and... I don't have this yet.
And can there be many assemble widgets at once?
There can, but we don't handle this properly right now. I mean, there can. I wish we could. We don't have code for that yet.
Then it would have a different set of registers.
Yeah, like here. This is another thing we are not doing yet. So when the plan is, whenever a register has a non-zero value, we will add this to the display. Right now we are showing just one register, AX, always. But ideally, they should dynamically appear. This is actually what we are going to do today. We'll try to add more registers, flags. Actually, I don't know what's the value of this register, so... This is another loop. Let's run this. I know we should have executed the loop now, but I don't see it being executed. Yeah. Okay, I will do one thing. I would like to be able to print the name of the instruction. I think it's just useful. This assembly text here. No. Okay, now when we exit through some assembly instruction, we will print the name. Very strange. It looks like... I would like to know what's the state of the CX register after this instruction. Maybe we are not restoring the state of registers when we start execution. Who knows? What is that? Strange bug. Okay, I think the stuff that we have so far we can probably submit. We have a nicer AX image. Okay, so the next thing is probably going to be to draw the other registers inside the assembler widget. Okay, we have this children array.
Elise says,
You read comments?
Yeah. You mean on YouTube? Yeah, I do. YouTube is very bad at sending notifications for comments, but whenever I see the comment section in the studio, I usually check them out. I'm getting like 1 comment per week, so it's not much.
On the voice of Lord Bell.
Yep. And you can pick your voice on liveautomat.org in the account section. This way to link your account and select different voice. Those are all the voices we have. Quite a lot. Okay, we'll have to do one thing. We will have to start the tick model. So far, assembler widget, make widget, returns assembler widget, this one, it doesn't have the tick function. And tick function is kind of key. There we go. Okay, and what we will have here is this is the place we will actually get the child registers.
Maybe if you're watching two voices, it's
It's the UI is custom, but under the hood it uses tortoise TTS. I think it's this one. Seems like it's this one. It's just a nice web API. I don't know what's up with the TTS today. It has like a stroke or something.
Have some fun here.
Yeah, it really has issues. It really struggles today. Okay, I just tweaked it a little bit so that TTS voices should silence the music a little bit. Anyway, ticking. Where should I store the state of registers? Should I store this in the widget? Or maybe in the assembler object? I think this one already has the state. Because controller internally, it needs to maintain the state to restore everything. So maybe I could restore this. So restore, I mean, So the state that controller has, it is stored in the debugger thread, so it's different thread. We cannot really access it easily. I'm using message queue for communication, so no mutexes, no atomics. Okay, I think this is the right API. I'm not changing this API. I guess widget will have the state of registers. Like that. Actually, I learned a very cool trick some time ago. It's that C++ shared pointers, they have this feature where each pointer actually stores two different pointers. So the size of this is 16 bytes. One of the pointers points at the control block and another points at the actual value. So it actually holds two things. The thing is, the value can be pointing at a totally different object. It doesn't even have to be a member of the original object. So instead of having weak pointer object, I could also have weak pointer assembler. Pretty much. And I guess I'm not sure if we really need a pointer. To the assembler. Okay, if it's a weak pointer, then it could also be a weak pointer to the assembler widget. Actually, I'm wondering whether it makes sense to have this exist outside of the assembler as a separate object that represents a register. Maybe it doesn't. There is no such field, so this won't work. We need to ask for the current state. Oops. Yep, state is here. This should pretty much never fail. We should probably do some locking here, but not super necessary. In the exit callback, we'll do one more thing, which is going to be There should be a way to update the animation somehow. I really think there was a shortcut for doing this. Oh well, apparently we have to write something ourselves. So from the root widget, Okay, that should still work. Let me just comment out broken things. So luckily this will be efficient, this operation, this invalidation. We just need to iterate over each widget store and over this map. Where did we crash? Okay, what I changed here didn't break anything, so I can remove this. Almost everything here is virtual, but we can just we can introduce the first non-virtual function. I wonder how multi-threading is going to play with this. I think rewriting this in Rust might be a good idea. Just for the concurrency. Okay, do I have to include the root widget? I have. I'm afraid I will not be able to call find. because I don't have equality defined. So this is going to be pointer to the widget. Okay, so this function compiled, it works. I think I have to restart language server. It's having issues following the code. Anyway, back to the tick function. Or not tick, the exit function. After we exit, we have to wake the animation because the registers may have changed. And we don't need any location for that. Nice. Okay, I have to fix this crash. I messed something up. I have no idea what actually. Maybe here. Maybe here. This is quite likely. Okay, this is strange. So register widget. Oh, I see. Yep. The issue is very subtle, so this weak pointer is not available until construction of the parent object completes. I really dislike this, I really do. But we can fix this easily, or maybe not so easily, but we can fix it by getting rid of this assembler widget from here, from the signature, and from here. We'll just put 0 here. Oh yeah, I'm not reading the right registers. So after I do the tick, then by the way, I think I could create a copy here. I have an idea. In addition to register index, I will also hold a register value here. Come on, should be fixed now, right? Yeah. And during the tick function, forget about this draw. We will focus mostly on tick now. How many of them do we have? 2, 4, 6, 8, 15. Okay, now it's being properly woken up. Oh, this is just an 8-bit register, yeah, so when we roll out around the first 8 values, then it disappears. Okay. Okay, now let's see if we can Okay, let me do one thing. So we have an array with all of the register widgets for all of the child registers, right? Child register widgets. Yeah. Now I can go through registers, and if the value of this register is 0, and we have no widget for this register, and then we can just continue. Otherwise, if we don't have a register widget, then we will create one. Cool. Okay. Then we can grab this child, check if the value is different, potentially wake it. Now I can fix the constructor so that we do not have any child widgets by default. Okay, this may actually cause some funky effects because we are changing the widget hierarchy during tick, so I'm not sure what will happen. Okay, it's not bad. Now let's try doing this. Okay, now we had suddenly 2 widgets and something weird happened. Segmentation fault, obviously. But a new child appeared, so that worked. Something weird is happening here. Okay, we can trigger this crash if we just show 2 registers. Yeah, I know the issue. Now we have 2 registers. Let me just run the DX. Now we have to push them away so that they should not touch. Cool. Now we are going from 0 around. Also see the CX register. So this is the one which caused problems for me, which I didn't know how it actually worked. Let's try to run this now. Okay, so it was set to 10. Then we executed the loop instruction and it jumped. Very strange. Jump short if count is not equal to 0. Ah. Let's change the description. Actually, we can use this information now to fix this piece of code, and it should work, hopefully. Let's run it. Four, 3, 2, 1, 0. Actually, something happened here. Exiting through move CL. Next. This looks like a bug in machine code. Serializer. So instead of exiting through this instruction, this is blinking for some reason. This one should blink. We're exiting through the next of this one. I think I know. It's because of how we handle terminators. Let's check this. Let's try this. Because conditional branches are also terminators. No, actually not. Is unconditional branch. Yeah, this is what I wanted. Nice. The counter works. You can see the values of registers as it executes. Very interesting. So now this crashed. Okay, so here is a sample program written in a mixed assembly and Automat. Let's put it on 720. 720 is a really nice number. If you look at the factorization, it has many, many factors. Okay, I will do a break and grab some lunch. So something like this. And after I finish, I would like to put more registers here. So when I have more registers, I want them to shrink and push each other. They should be like, they should be kind of flying in this space. And that's the that's the kind of feel that I want to have. Anyway, see you in a couple of minutes. Okay, I see nothing has crashed while I was away. That must mean there are no bugs here. Oh yeah, this is constantly lit right now. Oh yeah, this is another problem. When I disconnect connection between two opcodes, I'm not updating the machine code. Something rather important. But we will do this. Okay, I will add this to the to-do list. Track which registers should be shown. We've done that. Should animate the flags. So this is actually what we are doing now. That was the plan for the rest of the stream. We made the proper axolotl. We are following the next connection, and now the rest of the stream we are just adding fanciness to the assembler. On this side, on the assembly side, we should do this update whenever connections change. Okay. So I don't care about exit callback. I care about tick. This is the important function. So what real estate do we have available? It's mostly a rounded rectangle, and each register is another rectangle. Let's do this now, this layout. So I think let's first show our so this is our assembler, and within the assembler we will have let's show them like that, registers. So when we have one register, it could look like that. This is a nice look. So it's aligned in the center, in the very center. I think somewhere on the bottom we also have buttons for pausing and resuming execution. It's kind of slightly too much for this small experiment, but what's up with this connection? Come on. let's keep in mind that there could be more buttons on the bottom. If there will be more buttons, then to maximize real estate, we should probably align things horizontally, because on the bottom, again, we will have some space taken. So this is how we'll show two registers. They will be smaller, and I think the spacing from the border and between they cannot be equal because we need a lot of space for like the hex values on the right. So here there will be those hex values. On the top there will be an icon of the register. I also wanted to put something on the bottom so that you could edit the value directly or see the value directly as a decimal, because hexadecimal is not super convenient to work with. And how could this look when we have 3 registers? About this text widget, maybe I will put a text widget at the bottom. The whole reason for having a register widget as a widget is that it can grab focus, so it will work nicely with the keyboard. It can receive mouse events when I click this stuff and so on. When we get 3 registers, then we can show them. I think the only way to show them is as a triangle. I just wonder which one would be better. I think something like that. Actually doesn't. No, I think this one should be on top. So this may clash with the icons, like buttons that we will need on the bottom, but I think this sort of triangle it just feels nicer. It's wider on the base. Okay, and when we have 4, it will obviously be 4. What do we do when we have 5? Five registers. Obviously we'll have to arrange them in a line. Let's make them smaller yet. Actually, no, the bottom one should be filled first. Then we'll go to 6. I'm not going to draw 6, let's draw 7. Okay, and naturally we'll be able to go to 9 if we follow this. And how do we show them when we get to 10? I think then we have to basically switch to even smaller size. Okay, I think this is it. This is our layout for 10 registers. And with this layout we'll be able to go up to maximum of 15 registers. I mean, this is as many as we have in the state structure. So the reason I'm going with this space-like approach is that CPU usually has different types of registers. So those are general purpose registers, but there are also floating point registers, there is also stack. There are also like random memory buffers. I hope that with this representation, this like window into space, we'll be able to show those different data types as different objects in this grid, in this space. Let's try to implement this layout. Perfect. So we are getting the number of children. So to get the number of columns, so we do square root. Sorry, square root, or rather ceiling of square root. So when we have something slightly larger than 1, we get 2 columns. When we get something slightly larger than 4, we get 3 columns. When we get something slightly larger than 9, so 10, we get 4 columns. Okay, next. I think we should calculate, how many rows we will have. So if I have like 3 values and 2 columns, then this formula will tell me how many rows we will need to populate them. And the plan is we are filling all of the rows from the bottom until we get to the top one. And the top one is only going to be partially filled. We could have a more clever layout, but not sure. We could, for instance, grab those 4 top. That leaves us with 6 other registers to fill. So we could put those 4 on the bottom, and the 6 could be larger on the top. That's one option. To kind of maximize the usage, the space, the useful space, the clickable space. Anyway, let's go with this simple approach. Okay, so in the first row, we'll have in terms of order of registers. Actually wonder what should be the direction that we go. Should we go like that? can go either like that, or like that. Or we could even, no, we are not going to do top to bottom. I think the reading order will probably be better. So this one. So we are starting with the top row. This is going to be array X, B, C, D, and so on. I think I will sort the child array, so we draw from the top register always. Okay, this means that we are always going from the more important registers. And what is our N? Each widget has local to parent. This is our transform matrix. Stop the ticker. Enough for now. So in each register widget, so each of them has some size, base rect, and a bounding rect, which adds some margins on the side. I think I will use this base rect for sizing this. Or maybe so the thing is, it needs 1 centimeter on either side. I think we will have to hardcode this logic here. In HTML, in CSS, this would probably be possible to express the layout that we want somehow. That would be some flexbox probably. But we have to do this manually. So the plan here is that we will first we'll try to find the target scale, find target position, we'll get current matrix, we will decompose this into current scale and position, then we will animate it a little bit. And set new matrix. This animation is done by the parent because the registers, they don't know what's the size of the parent. They shouldn't care about this really. Okay, I'm setting this 1 centimeter because, sorry. I'm setting this margin, yeah, so that we can compute the proper scale. So this is our total width that we will need if we didn't want to scale the registers at all. I think we only need total width. Actually, no, we also need total height. Maybe in a moment. So now we need to figure out how much space do we actually have available. couple valuable values. This inner rect is what we need. Let's make this global. Then for each child we should find its position. The origin... I hate scrolling on X. For some reason it's so broken. The origin is... oh yeah, maybe I can mark it like that. Here, in the center. So let's compute this total height. I think we will need it now. Or maybe not. Yeah, I think we don't. So from the I, we should be able to compute the row. Okay, so row, column, looks good, but this not so much. For now, let's say y equals 0. What can we say about the column? We know that the middle column has 0 deflection. And for each extra column we should move by width. Plus margin. Minus some offset, and this minus offset we have to calculate. What happened now? Strange. We tried to set a non-existent matrix. Let's try again. What is failing there? Okay, so this is our one register. Now, actually it's fun because now we are scaling this up accidentally. We didn't intend this, but it's a happy accident. Let's try starting this thing. Okay, now we have 2 registers. I think this scale should be post. Cool. Now look at that, we have like 2 pieces of assembly executing concurrently now. Oh, it finished. Yeah, the same bug was here, so the condition was good. Cool. This doesn't seem like it's executing, honestly. Okay, and the offset. To make it easier to test, I will add some default registers in the constructor. Actually, 3 is perfect. Okay, I will take a ruler. I have to measure some things. I don't have a ruler, I have a tape. I just want to measure on screen if the margins are right. So here I have 2.8 centimeters. Yeah, looks right. I didn't really thought this through a lot, but yeah, looks good. When it comes to Y, should probably do the same. This will push the widgets down. Or up, actually. So maybe I should put minus here. Okay, there is one thing I wanted to try. I wanted to see if I can do clipping, because if I can, that would be awesome. If this works, then I am truly impressed with Skia, because it means it works despite my ugly rendering pipeline. Yeah, seems it does. We can do the clipping. This opens up so many possibilities for animation. Now we can actually animate stuff and pretend that it's actually behind this window. No. Session worker stopped has failed. Interesting. Okay, so this register is counting, we are just not displaying it properly. We'll have to wait for quite a long time until it showed some flags disappearing. Okay, we should offset them vertically now. So this offset is not quite correct because you can see the AX register is... it's not exactly where it should be. I think instead of these columns here, we should have effective columns. Or so now the top row should be nicely aligned. Okay, this value should be equal to 1. Let's log this. Should be equal to 1. Because total cells is 4, and yeah, looks good. Columns should say 2. So when I take columns in row, columns, this is true here, 2. If row is equal to 0, which it is, and then this is set to 1. Okay, and 1 minus 1 is 0. I think that was the issue. Yeah, now it looks good. And now we should probably offset this in the other direction, like vertically now. I think we have to do something similar. This value, I think there are a couple places where we use this. here we have height. Multiplied by this. Let's see if this works. Perfect. Yeah, we even have some space on the bottom, this 1 centimeter. This should be plenty to put a button here. Nice. Okay, now let's animate the registers. We have a matrix. We could animate this directly by interpolating the values of the matrix. But I think it's nicer if we can recover. Okay, so we've done those things. And now we need to do this part. Oh, and actually, it's just temporary. Okay. I'll do a short break now, and then we can finish this without the animation. Sorry, I was muted. Yeah, I had this indicator in the top right which shows the connection to YouTube and to other chat services. So let me see if it actually went down. Okay, it didn't quite went down, but the pulse stopped. Yeah, so when the pulse stopped, it means that we have been disconnected from YouTube. I actually wonder what happened there. Let me restart this again, quickly. Okay, things should be working now. This is first time something like that happened, but in the console I haven't seen any error messages. Oh well.
Knight says,
I'm looking for a request management system for a company. How did you manage interdepartmental requests at Google? Is there a ticket management system you can recommend? I think GitHub's issues system is excellent.
Yeah. So this is the ticketing systems that we used. I wouldn't say it was great, it was just a bunch of forms. Nothing really amazing about this. I would honestly say that the way GitHub has managed tickets is probably better than what we had at Google. Yeah, I'm green when it comes to those things. At Google, honestly, we used a lot of email for everything, and usually sending an email was okay. It wasn't as reliable as tickets, so it's possible that somebody loses your email, but there was this assumption that when you send an email, this was the default communication platform in the company.
Memo Government says,
Oh, hey there, beginner programmer here.
Hey, hello.
Knight says.
Thanks.
Member government says.
And DDD, I understanding nothing.
No worries. Honestly, for learning programming, it's much better to like play yourself than watching streams. It's the same as with learning languages. Like listening, it teaches you understanding, but it's totally different skill than speaking. So you can listen to a foreign language for decades and be unable to speak a word, so you can understand it perfectly, but saying anything will still be a problem. Same with programming, I guess. Or maybe, I'm not 100% sure, but I think it could be similar. What am I doing? Okay, so if we managed to decompose, then we will do the animation. So we've done this. And this. Now we need to animate this.
Knight says.
I don't understand the MRI scans given at the hospital.
Member government says.
Ah, yes. I am nowhere near the expertise required to watch this. It's like listening British people when you learnt some sentences.
I'm not sure what will happen now. It may blow up. Maybe I should do post scale or something like that. Not sure. Okay. Let's try this. Is it scaled? It is. I think it is. Cool. Now we will do animation. Now the scale should be animated. Maybe we need to return true to indicate that we are animating. Yeah, it was animated a little bit. Okay, next thing we should animate would be the position. Maybe in documentation there will be some help. Which of those is translate X? This is what I'm wondering. Okay. M3. Can I somehow get a reference to a cell? Nope, it's private. Why are there no references here? Okay. There are. It's not quite right. Yeah, they are flying a little bit too far. This is how it should look. And this is what we get. We'll do this differently. Maybe I don't need to decompose this. Maybe I can just... grab the original values.
Knight says,
Have you tried Grok? I tested it by generating some code and it gave really good results.
Yeah, so I've been playing with composer mode in Copilot. In Cursor. It was very nice. It was very good in a new project, in a very clean code base. My experience is that it's very hard for this thing to adjust to existing set of conventions or functions. I tried a couple of them. I haven't tried the new Claude. But really, whatever Claude does, I need to understand this.
If you want, you can ask a simple question to GPT, Grok, and Claude to see which one gives the best result.
The question is the problem. If I can formulate a question, I can answer it. Let's try this. I think I don't have Grok here, but I have Claude 3.7 thinking. Seems to be the top one in benchmarks. This is not how this API works. Nope, this is wrong. But I have a plan. From vector4 I can access reference, but not from here. Yeah, in this question panel I could probably provide it more context, how to use the API, how to use Skia, what are the effects, how do they look like. Maybe then the model would be able to solve this. But this is more work than actually solving the issue.
I think due to a lack of documentation, not only Claude, but also the others probably won't be able to answer this easily.
So he doesn't really need documentation. By looking at the existing code, he can see that the return value has different type, and that this is, one of the arguments is called target. Somebody who's totally fresh, who hasn't even seen the function signatures, it's possible to figure out how this function works, just from looking at how it's called. It just, for some reason, it assumed that this code isn't compiling. It is compiling, it produces strong results. Okay, this is good, this is good. It's a different way to do it. It will animate correctly. In this simple case that we have here, it's not going to cause any issues. Okay. How is this too far? Oh yeah, it's true. I should grab target mat. Those. Now it will be correct. Maybe it's even faster than the previous one. I don't like animate values of matrices directly, because then I can now run this and we'll see a new register appear. Yeah. Okay, when we are adding new register widgets, we can have them fly from somewhere. They could fly from the bottom. Let's see. Actually, they flew from the top. That's fine, that's fine. Cool. Should be probably way faster.
It took me a whole day to get AI to create a visible header in React Native that changes based on the user scrolling. The solutions it found were animation examples from other documents.
Yeah, in the new code base, AI can work very well. As long as it's creating new things, for some reason it just doesn't make as many errors. Okay, so we have those basic registers that we can display. It would be nice to why doesn't this work? Set to 0. That's right. So we can see this animation here. This is something I also want to animate. The flags. The flags should they should move. They should, I don't know what, but they should do something. We are rendering them as vector images, so we can animate them. It's totally within our power. It would be nice if they actually, you know, moved on the wind. Actually, I will run this. It didn't work. Oh yeah, it only changed the last 8 bits. That's the reason. The upper 50 something is still unset. Anyway, the registers, the assembly kind of starts working. Let's do the animations now. So layout is complete. I think border shading should be simple. Let's do this right now. So the idea here is that this external part of the border, this should be flat, and the internal one is angled. So here we should put some gradient. Here. So instead of flat color, we will add a nicer shader. Let's look at the concept art. Not this. I think it's this one. Okay, so on the top we'll have one color, darkish color on the top. Then here in this section it should transition into this border color, and on the bottom we'll have third one. The top color, let me grab this again. Then we will need the central color. Okay, this is something that potentially Claude could help with. Let me use escape, erect. Because I think this may be more familiar. Okay, and we will have to switch the model. Let's try this Claude Sonnet thinking. Unable to reach Anthropic, come on. Yeah, it should use the sweep shader. Okay, this is wrong. This is definitely not, those are not the correct angles. But it's a good starting point. Let's apply this. I need to include some... Okay, it's already here. So what's the issue? XY, color array, position array, count, and then flags, which is optional. Not exactly what we wanted, but like I said, it's a good starting point, at least. We should not start from top center or anything like that. Let's go to make sweep. So we should start from the right top. We are going to skip color 0. So we're starting on the right, and then we have top right, and then it will be top left. None of this matters. We will have to fix the angles. I just want to set the colors correctly. Okay. The only issue is now that the gradients, they are not starting at the correct positions. Okay, this is critical for us. Those functions, we will use them a lot. Okay, now I can use this ATAN and divide it by 2 pi, something like that. Actually, this is something where sin cos would be nice. Accept vec2, and we should return this. So AI was useful here because it correctly it filled the template and added a bunch of comments which are nice. Cool. Now we have a nice shading here. I feel like something's wrong with the top color. Is it here or not? Let's see. It's not. Let's log the positions. Okay, there is an issue here. Yeah, it should be right upper. Everything else looks correctly. Okay, some unknown crash. I will have to debug this. I just want to see if shading is correct. Looks alright. So the whole idea here was that in those sections we have actually nice shading. Center point. Those comments are completely useless. Use this one. I think it will look nicer. Yeah, simple stuff. What else do we have here? We have those lights, right? These lights. So we have the lights and also it feels different, this color here from the concept. Let me see If I grab this color, I think the difference will be with those lights, because those lights, they should make this whole thing warmer. Okay. Let's say this is done. Let's do the lights now. I think we could have a fixed amount of lights. I was thinking about having a function to calculate how many of them and where we could put. But that feels kind of strange. So I have this rounded rectangle. It would be nice if I had a function that would tell me where the lights should be placed. Let's add a function like this one. Okay, this could be complex depending on what kind of rounded rectangles we want to support. Let's maybe mention that we only support simple rounded rectangles. Okay, and let's say we will always put 1 point directly in the upper left corner. Or maybe right. Yeah, it's just a sequence of values, and we will be kind of walking along those values. Something like a manual iterator. Actually, maybe cursor is going to be able to fill this. Let's do a new composer window. Actually, I didn't switch this to agent mode. It should be agent. Looks good. Let's see. So we are starting here. Yes, exactly. I wouldn't say 0 to 45 degrees, but okay. Interesting. I think it placed the initial point wrong. That should probably be plus. This should be plus something. Okay, and those offsets also seem wrong. Okay, and we should not do this subtraction here. Okay, maybe that's actually not a bad idea. To not carry this over. I'm going to copy all of this here. The idea is that we can forget about this logic, this advancement logic. It's very regular, so we don't really need it. Okay. Nice. Left corner is actually, this is how we are going to do it. Okay, those comments are totally unnecessary. I could also do it like that. But start with some distance, non-zero distance. bottom line. Cool. Bottom right corner. Cool. And this is actually going to be the same face. Okay, let's see if this works. So at this point we should have positions. Now we can iterate over them. And draw circles. Okay, this one is correct. Good, 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 good. But here something is missing. Okay, the number of lights seems correct. So there is something with the right line. Right bottom plus radius plus distance. Looks good. Initial angle looks perfect. Absolutely perfect. So we are adding the step. If it's greater, then we subtract. And we advance to the next. Okay, honestly, it looks like we are calculating the circumference wrong. I will draw this on top of everything. See how that will work. We have some things positioned in the corners. I think this will help. Or not. Yeah, I don't think I should subtract one here. What is the initial one? Initial one seems to be in the correct position. this is something that shouldn't change anything because it's a rectangle, so yeah. Okay, maybe the distance is equal to 0. That's my guess here. It looks like we are at the start of this point. So points of I is equal to rect left. When we are in the top left corner, what's the angle? Okay, apparently we are never in the top left corner. Okay, I see the issue. Nice. Now we just need to draw our lights. In the design, they have a very nice color. But that's not the end. Now we also need to draw the everything else. There are a lot of very subtle shadows on the border. I will add more of those lights. Let's go 4 times 6. Because I want to have a center light on every corner. Nice. create this warm effect, we would have to probably clip, just so that we only draw on the flat border, and draw a large gradient like this one. Using this color. Sigma. I have no idea what would be that. Let's go 1 millimeter. I think there is some warm color now. It's barely visible though. I think we should make this larger, like 2 millimeters. And the mask filter itself should also be more intense. Oh, this is outer blur style, so it may not draw properly. Let's see. Oh, wrong one. Actually, I could probably draw those lights as large circles. Each circle would just be a gradient going, between those values that we have along this line. It will start fully transparent and then go to this hot red, then get dark, and then we would have this sort of light. There's some variation, I think, within the light. Slightly darker outer edge. So maybe this is the way we should do it. It will be less draw operations. We will start with this hot red color. But fully transparent. And then regular one. And then we will go to this dark color. And then we'll have this warmer one. And in the center, this one. Next we need positions. And we should start actually from the center, so let me invert all of this. And no flags. Yes, now we can forget that. Okay, there is something here, but not much. Okay, I need to give a radius. Okay. Way too red. 3 centimeters. I went too far. Let's try with 1. I think it's still going to be too large. I mean, it's not that bad, so we actually have clear light positions around. Okay, why is it not... Okay, this is transparent, okay. They must be strictly increasing. Okay, that didn't solve anything. You can clearly see where lights start now, but I don't see the nice part in the center. Oh, okay, I see. The model messed, I guess the model messed the colors. That's fine, that's fine. We can fix this. Okay, be right back. Finish transferring the colors. Now this could work. Yay. Yeah. And they look decent. It's very jagged at the edges. And the decay, so because it's linear, it doesn't look realistic. Okay, are there any flags that we could add? Interpolation method from flags. Okay, we could specify a color space. I just want to reduce the aliasing issues. But there is probably no way to do it like, properly. It would require Skia to sample each point multiple times. I mean, yeah, when I zoom in it's suddenly smooth, but that's not the point.
M4 says,
Yo,
Hey, I think we could break this shader into two shapes. We'll have this outer shape, which will draw the shadow and the light on the edge, and the inner light, which will draw just as a circle. Let's try that. So internally, let's do shadow twice. Okay, now we are drawing just the outside part of the circle, right? Should be perfectly fine. Let's call this glow colors, glow positions, and glow paint.
Anikens, you're good with CSS. Right now, I'm trying to add an outline to text, but a stroke is inside, and my only workaround is just making a thick shadow.
You have an option. So in CSS there is this WebKit CSS outline, something like that. It's a very limited attribute, but you can use this to add sort of a text stroke. It only works on Chrome, so nobody solved this. You can use CSS. CSS would be probably the way to solve this if you want this to work properly and on all browsers. Sorry, CSS. I mean SVG. You can create a tiny SVG with a bit of text. But text outline, this is still an open problem for CSS, unfortunately.
It's for a CSS edit on a widget on OBS White.
Let me see, because I actually have something very similar in OBS. Let me see how I do it. Give me a moment.
Artist's text shadow. 2ppx0, 2ppx0, 0, 2px0, 0, 2px, 1 ppx0, 1 px0, 1 px0, 1
Okay.
px, 1 px0, 1 ppx is what I'm doing currently. Sorry for the TTS hell mail.
Okay, actually, how do I do it? I think I'm using some outlines here. I think this part uses outlines. Nope. Yeah, but the trick that you mentioned, it works, but it generates very jagged edges. Sorry, I don't have anything on hand that could help you.
All good, thanks for the help either way.
Sure.
M4 and Go just followed on
Hey.
Twitch.
Hey, wait. Actually, wait. Stop. When you followed, I actually noticed there was an outline, a text outline there. So I just need to find the code to do it. It must be somewhere here. Streaming about static. Okay. I guess that's fine. Let me just open cursor. Recent bot. Okay, there should be a function somewhere here that shows those notifications. There it is. Yeah. It just dash WebKit text stroke. It's not perfect because I think this stroke is on top of the text background, so it makes the letters a little bit skinnier, but it will work.
Yeah, that's inside the text. Which is why I was using the workaround.
Okay, I think there is one more function very similar to this. Function, one similar attribute. There was something that changes the drawing order.
And can't use 1px on that either.
Yeah, I use the trick with multiples of the same element on top of each other quite often. So if you can duplicate the text, you can, have the stroke on the background and fill on the front. But then, you have to duplicate it. Yeah. And CSS, sorry, SVG. Honestly, if I had to do this in like a professional setting where it has to work, I would go for SVG. No question about that. Okay, this subtle shadow. Crash, of course. But okay, this is it when it comes to lights. We've just added lights. We can also change whether they are on or off. Yeah, depending on assembler state. And I also wanted to add some kind of exponential curve to them. Let me also try this exponential curve. Sort of exponential curve. Where is it? I have to fix those crashes. Yeah, I think this is okay now. Nothing's perfect, but we have to live with it. Okay, this is for today. On the next stream, I don't know what we are doing. We will be improving assembler more. I think this is probably the important thing to have. Those two things. Make it compile on Windows and updating the machine code as we execute it. Essentially, we want to fix all of the crashes. Okay. So this is it for today. See See you next time. Bye bye.